Welcome everyone to Zahid's data mining channel once again. My name is Zahid Islam, and I have a YouTube data mining channel, which is, you can see here on the screen, Zahid's data mining channel, and I have quite a few videos on various data mining tools and techniques and approaches. Today I will be presenting one of our software that is freely available in Weka. You can download it and you can run it in order to build decision forest from cost sensitive dataset, from a cost sensitive dataset. Now, what is a cost sensitive dataset? So in order to understand that, may I suggest you to watch one of our videos, previous videos on cost sensitive dataset. And we presented actually an algorithm for building decision forest from cost sensitive dataset before, and it was published in information systems. So this is that paper, that cost sensitive decision forest algorithm. And I have a video, YouTube video already available, this one, which is decision trees for cost sensitive datasets. Please feel free to watch the video so you understand the background, what is a cost sensitive dataset, and how we build a decision forest. What is a decision forest? How we build a decision forest from a cost sensitive dataset, so that we can discover some knowledge pattern from the dataset, and we can also predict future records, the class label of a future record. So you can understand all those things from that video. But in today's video, I will introduce the software that can actually build a cost sensitive decision forest for you, and the software is freely available. Although you can learn cost sensitive dataset and all these things from the previous video, just I'm giving a very brief idea of or introduction to a cost sensitive dataset. Here you can see a dataset where there are multiple patients, various patients. So each record in this dataset is representing one patient. So the first patient age is 95 and his alcohol addiction is possibly high, tobacco addiction is high, and his inflammation condition is chronic, and his diagnosis is cancer, say for example. And there are multiple patients. Now most of the patients here are non-cancerous, but some patients are cancerous. They have been diagnosed with cancer. Now in a cost sensitive data set, the class labels, that is diagnosis, can be very cost sensitive, in the sense that some of the class label values, some of the class labels can be very costly to be misclassified, to be incorrectly predicted. For example, if you have a cancer patient and if you have a machine learning model or a decision forest, decision tree, etc., that predicts his class label to be non-cancerous, the patient was cancerous, but your model is predicting him to be non-cancerous, then the consequences can be very heavy, as opposed to if you have a patient who is non-cancerous but your model is incorrectly predicting him to be cancerous. So this is an example where things can go very wrong. So that is what we call it, cost sensitive dataset. So when you build a decision forest from a cost sensitive dataset, then your decision forest algorithm should take these things into consideration and try not to make mistake on the costly things. Now in this video, I'm showing you how to actually download our software, which is freely available online, so that you can build a cost sensitive decision forest using our algorithm that I showed before. Now Weka, this is Weka 3.8. You can download Weka freely. This is a freely downloadable software. I'm sure many of you have already used Weka. So once you download Weka, if you go to tools, you can go to the package manager, and when the package manager GUI window comes up, you can refresh the cache repository cache, and then you can look for our algorithm, which is called CS forest. So if you type CS forest and then if you look for it, then you will see CS forest package there. Just type CS forest and then you will see CS forest package there. You can click on it to see more information about this and then click install. To install CS forest, it will be installed, and then if you go to installed software, you will see CS forest will appear. So this is how you can download it. This is as simple as this. You can download our software in Weka. It is already there, so you just need to install it. Then after that you need to restart Weka as they recommend. Once you restart Weka, you can go to the Explorer and you have a data set, of course, right, for which you want to build a decision forest. Then you just need to open that data set. Okay, so in this case I will be accessing the diabetes dataset that comes with Weka automatically. So I'm going to the same folder where I have installed Weka and opening the diabetics dataset. Here is my Weka folder, and under the Weka folder there is a subfolder called data, and within that data I have a dataset called diabetes. I'm just opening that dataset. Now I can see the dataset in the Explorer of the Weka, and here is the class value of the dataset. There are two possible class values: tested negative and tested positive. So some of the patients are diabetes patient, and some of the patients are not diabetes patient, negative, right? So it's similar to the previous example that I gave, that cancerous and non-cancerous. So I can assume that this is a cost sensitive data set. Now if I want to build a classifier, I will have to choose my classifier, which is called CS forest. So here if you go to the trees, you can see CS forest. There are a few other classifiers that are also programmed by us, for example forest PA, for example Siers4, etc. But in this particular example we are using CS forest because this is the class sensitive algorithm that are proposed by us. Then once you choose CS forest, you can actually choose various parameters of CS forest. For example, number of trees. Let's say for simplicity we can decide the number of trees in the forest in the ensemble of the dataset. It will be 3, and we can say minimum number of record in each leaf will be 50. So every leaf in the tree will be 50 at least. So if you are not very familiar with what a decision tree is, what a tree is, etc., then please feel free to watch my other videos on decision trees and forests, etc., that can explain things well. So now after I choose this, there is also another option here for cost metric. Here you can put any cost values. Say for example in the current cost matrix it says that a false negative, that means you are predicting a patient to be negative but is false, that meaning that the patient is actually positive, and that cost is 5 times more than a false positive or true positive. So if the patient is true positive, that means if the patient is diabetes and you are predicting to be patient to be diabetes, then there will be some cost, of course, meaning that you have to give the patient a treatment, etc. This is a diabetes patient, you have to arrange consultation with the doctor, something like that. So it's a domain expertise, so domain experts can tell you what is the cost for that. Now if you predict the patient to be actually not diabetes when the patient is diabetes, then we are assuming that the cost is 5 times. Now this cost is very domain specific, and domain experts can give you an idea of the cost ratios. So please watch my other video on cost sensitive decision forest algorithm that I showed at the beginning, that I showed you on my YouTube channel at the beginning. So please watch that one for better understanding. But as a data miner, you may not know these cost ratios all the time, but your clients, your users can actually give you this idea. Now after you choose this cost metric and all the trees, etc., you have already uploaded the data set, and you can also see various attribute values of the data set, and the proportion of diabetes and non-diabetes patients within those attributes. So you can do that. But now after you have chosen all these parameters, you can build a decision forest. So in this case, how many trees we wanted to build? We wanted to build only 3 trees. So here is your tree 1, tree 2, and tree 3. And each of the trees, it says that if the plus value is less than equal to 106 and mass value of the patients is less than 26.2, then the patient is predicted to be tested negative, meaning that the patient does not have diabetes. And it also gives you lots of information about this particular condition when plus is less than 106 and mass is less than 26. That in that situation, there are 85 patients with negative from your training data set and only 0 patients positive. So there is, if you consider this case, this leaf, all records to be negative, which it is doing wisely, then your cost will be $0 because tested negative, right? So then all will be true negatives. So if you consider all of them to be negative, then all will be true negative, and the cost of the true negative was 0 in your cost metric. If you see, cost of the true negative was 0. So from that, your total cost is going to be 0. Whereas if plus is less than 106 and mass is greater than 26.2, then your best bet is to consider them as negative as well, and then the cost will be 165. That's because if you look at the distribution for your training data set within this particular leaf, you will see that there are 160 negative cases and 33 positive cases. So what was the cost for false negative? Remember, if we are here predicting the cases to be negative, so then these are true negative. So true negative is 0 cost, but this will be false negative. So there will be 33 false negatives because you are predicting to be negative, but actually they are positive. So false negative. So 33 times 5. If you remember the cost metric, we said 5 times. So the cost will be 165. If you had you decided the class levels, predicted class levels to be other way around, so that for example tested positive, then you would have these all false negative, and this would be your true positive because you are predicting positive. So true positive is 33, so and cost is 1, so 33, and 160 cost is 160. So 160 plus 33 would be 193, which is higher than 165. That's the reason here a cost sensitive classifier is saying that no, let's assume all of them are negative. So this is how it predicts. Now you can see the similar things happening for other trees as well. So you get the trees, you get some sort of understanding. Now if you get a new record, you can use these trees to predict that record. And how you can do that, you can also watch my other video that I am referring to again and again, that actually these two videos together can clarify things very well. Now we also can see a whole lot of confusion metrics and other statistics here to see what is the classification accuracy and performance of this classifier. Thanks for watching.